So our normal routine for working out the area underneath the curve, let's say f of x equals x squared between 2 and 5. Our normal routine would be to get b, take away a, and then divide it by the n number of strips. So we would divide this into n number of strips, and then we would say that the area here is approximately the area of all the rectangles added together. So this here is the height of our first rectangle, okay, and then this here is like our delta x here, our delta x being the width of our first rectangle. So when you get the height here, when you get the height of the first rectangle times the width of the rectangle, that will then give you the area of our first rectangle. And then this here is the height of our second rectangle. And then when you get that times the width of the second rectangle, so this is our delta x. So when you get the height of our second rectangle, let's say this is the height here, and then when you times it with the width, that would then give you the area of the second rectangle. So our normal routine would be to add up all the rectangles here, okay, and then dot 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 dot, and then add up all the rectangles. So we can say that the area of this whole thing here is approximately the sum of all the rectangles. And then a neat way of writing this thing here would be this, okay? And then our normal routine would be to spot that this here is a summation where it is a k that's changing about. This here doesn't contain a k, so our normal routine would be to spot that this is a constant, and then we would then take it out here. But for the time being, leave it as this. So hang on, let me go back one step. So currently the area here is approximately this whole thing here. So this area here is approximately this thing here. But we do have the right to do the following. Oops, hang on. We do have the right to do the following here. We do have the right to say, so currently the area is approximately this thing here. Currently the area here is approximately this thing here. Now we do have the right to do this. Now we can say that the area is equal to the limit. So now we are applying the concept of limits to this thing here. So we can say the area is equal to, here it's just an approximation. Here it is precisely equal to, and then take the n to head towards infinity of this whole thing here. So we do have the right to do this. Hang on, bear with me. So f2 plus 3 over k over n, and then times 3 over n. We do have the right to do this. Now, so currently we are here. Now apply the concept of limits, meaning increase your number of strips, increase your n to infinity. So you're taking an infinitely amount of strips. So we are now applying the concept of limits. That will then give us a precise area. Okay. So hang on. Let's go back one step. So currently we are here, where the area is approximately this thing here. Now apply the concept. So currently we are here. Apply the concept of limits. That will then take you to here. So we've applied our concept of limits here. Take a limit as n tends to infinity, and then it will become this. And bear with me. I will explain this later on. So the area here is approximately this whole thing here. Apply the concept of limits. So then the approximation here becomes precisely equal to. So we can now say the area is precisely equal to this whole thing here. Okay, so hang on. So this thing here is just a notation, meaning it's just a way we would write things. So hang on. This thing here is the height of a rectangle. This thing here is the height. This thing here is the delta x. So once we've applied the concept of limits, so we've applied our concept of limits here as n tends to infinity. Then this thing here, an approximation, becomes precisely equal to. Now this delta x here is really the width of our rectangle. But then once you've applied the concept of limits, then it becomes dx. So you can think of this delta x here as being, let's say, the width of the rectangle. So the width of the rectangle, let's say 0.003. So there's a slight width to this rectangle. Well, once you've applied the concept of limits, then this delta x here, this width here, becomes dx. Now dx here is in the realm of 0.00000000003, say. So this here is our delta x. This here is our delta x. This here is in a way our dx here. It is much smaller than this dx here because we've applied the concept of limits. So even this may be a bit too big for dx here. The point here is that dx here is tiny in comparison to delta x. So this thing here, delta x here, once you've applied the concept of limits, this delta x here becomes dx. So dx is still a concept of the width, of the horizontal width, but it is a tiny amount. So this delta x here becomes dx once you've applied the concept of limits. Okay, and this height here is really the height. If you have a graph where you have a function here, f of x here, if you put x into the function, it would take you. So this here is also in a way a height. Okay, so hang on, this is height. This is height, and this here is delta x. And then once you've applied the concept of limits, so apply the concept of limits where n tends to infinity, then this height here becomes this, and this delta x here becomes dx here. Okay, and then this summation here becomes this. So this is a way of summing up everything here. But the main point here is that once you're here, apply the concept of limits, and then this thing here becomes dx, and then this thing here becomes f of x, and this is the summation here, and this here becomes precisely equal to this. So area stays as area. So just bear in mind that this here is just a notation. It's just a way we would write things here. So when you see this here, it means that we've already applied the concept of limits. So when you see this, we've already applied the concept of limits. So from here, we apply the concept of limits. That will then take us to here. So from now on, when you see this here, you have to think you have to realize that we've already applied the concept of limits to get to here. Okay. And by the way, in our case here, where we're trying to work out the area from 2 to 5, we would then do this 2 to 5. I would explain this more on it another time. Okay.